Good day. Our group will discuss about complex numbers. A complex number is a combination of a real number and an imaginary number. A real number is a type of number we use in daily life, like 0, 1, 2, 3. An imaginary number, when squared, gives a negative result. The unit imaginary number, when squared, equals to -1. Remember to keep I so that we use to know it an imaginary number. The general rules for working with complex numbers as follows. First is the equality. To be equal, the two complex numbers must have equal parts and equal imaginary parts. Second, the addition operation. To add two complex numbers, the real parts and the imaginary parts are added separately. For example, A plus BI quantity plus C plus D quantity is equal to A plus C quantity plus B plus D quantity. 4 plus 2I quantity plus 2 minus 10I is equal to 4 plus 2 is equal to 6. 2I plus negative 10I is equal to negative 8I. Another example, 5 minus 3I quantity plus 4 minus 4I quantity is equal to 5 plus 4, 9. Negative 3I plus negative 4I is positive 7I. For subtraction, to subtract a complex numbers, we must subtract the real part from the real part and the imaginary part from the imaginary part. A plus BI quantity minus C plus DI quantity is equal to A minus C quantity plus B minus D quantity I. 5 plus I quantity minus 2 minus 8I quantity is equal to 5 minus 2, 3, and I minus negative 8I is positive 9I. Fourth, to multiply complex numbers, each part of the first complex number gets multiplied by each part of the second complex number. We just use FOIL method. FOIL stands for first, outers, inners, last. Like this. 3 plus 2I quantity multiplied by 1 plus 7I quantity. First, 3 multiplied by 1 plus outers 3 multiplied by 7I plus inners 2I multiplied by 1 plus last 2I multiplied by 7I, which gives us the result by evaluating negative 11 plus 23I.
For division. In solving division of complex numbers, remember that x sub 1 is multiplied by x sub 2 plus y sub 1 multiplied by y sub 2 over x sub 2 squared plus y sub 2 squared. Here is the example of division. Let z1 is equal to 8 plus 3i and z2 is equal to 9 minus 2i. Applying the formula above, 8 multiplied by 9 plus 3 multiplied by negative 2 over 9 squared plus negative 2 quantity squared plus I multiplied by 9 times 3 minus 8 times negative 2 over 9 squared plus negative 2 quantity squared. By evaluating, we get 66 over 85 plus 42 over 85i.
Converting between polar and rectangular coordinates. Here is how the formulas are derived. Graphing the values of x and y, we can get the value of modulus r for the polar form. From the graph of x and y coordinates, we can also get the value of theta. Recalling that tangent of theta is equal to the opposite y over the adjacent x. Solving for theta, we got inverse tangent of y over x. Substituting r and theta, we now have a polar form. Z is equal to r times quantity cosine of theta plus imaginary sine of theta, or simply r cis theta. Converting complex number from polar to rectangular coordinates, we just simply substitute the values of r and theta to formulas x equals to r cosine of theta and y equals to r sine of theta to form x and y rectangular coordinates. Now, here's an example to show you how to apply the formulas. Suppose we want to get the polar form of 3 plus 4i. We denote x as the real part of the coordinate and y as the imaginary part. Therefore, x must be equal to 3 and y equal to 4. Solving for r, we're going to substitute x and y into formula r equals square root of x squared plus y squared. So r will be equal to square root of 3 squared plus 4 squared. Evaluating, we get r equals to 5. Next is to solve for theta. Recall that theta is equal to inverse tangent y over x. Substituting the values of x and y, we get theta equals to inverse tangent of 4 over 3. Evaluating, we get theta is equal to 53 degrees. Substituting the values of r and theta, we now have 5 cis 53 degrees as the polar form of the rectangular coordinate 3 plus 4i. Next is to show you how to convert from polar to rectangular coordinate. We're gonna use the previous example to also prove that our solution is correct. So we have 5 cis 53 degrees to be converted into rectangular form. This process will be easier than converting rectangular to polar form. We just have to recall that x is equal to r cosine of theta and y is equal to r sine of theta, and substitute the values of r and theta, which is 5 and 53 degrees, from the given 5 cis 53 degrees. Substituting the values of r and theta, we have x is equal to 5 cosine of 53 degrees and y is equal to 5 sine of 53 degrees. Evaluating, we get x is equal to 3 and y is equal to 4. Substituting the values of x and y to the rectangular form x plus yi, we get 3 plus 4i as our final answer. And as we can see, it is also equal to the first example. So we just returned it to its original form correctly.
Hi, I am Dunamis G. Crisostomo and I will be teaching you how to solve the exponential form of complex numbers. The equation z is equals to r times e raised to j theta is a type of exponential form of complex numbers. Now, how it was derived? It was derived from the rectangular form of complex number z is equals to x plus iy. Now, knowing that x is equals to r cosine theta and y r sin theta, we can substitute these values on the rectangular form. Z is equals to r cos theta for x and plus I r sin theta for y. Extracting the r to that two function, we can get z is equals to r quantity cos theta plus I sin theta. Looking at the inside the quantity, the equivalent function of cos theta plus I sin theta is e raised to j theta. Now, z is equals to r times e raised to j theta. That's how was it is. For further more understanding on how to understand exponential form complex numbers, we can solve various problems. Sample, cos times 1 minus j can be solved using the exponential form of complex numbers. It can also be solved by various techniques of mathematics, but it's a faster way to use exponential form of complex number to solve these. Now, cos 1 minus j has a type of identity in trigonometric functions. It is the sum and difference of two angles. This is cos theta 1 minus plus theta 2 is equals to cos theta 1 times cos theta 2 plus minus cos theta 1. Sin theta 1 sin theta 2. Substituting the values of theta 1 and theta 2, we can get cos 1 times cos j plus sin 1 times sin j. Again, there is an identity for these two operations. Cos j is equals to cos 1. In hyperbolic function, it is an equivalent function of that. Sin j would be equal to j sin 1. Also an equivalent function in hyperbolic function. Note that the theta inside of this function is a type of region. Now, cos 1 times cos 1 would be equal to 0.8337, while sin 1 j sin 1 will be equal to j 0.9889. Then we get the rectangular form z is equal to 0.8337 plus j 0.9889. To express this in exponential form, we can get r and theta. R will be equal to square root of 0.8337 squared plus 0.9889 squared would be equal to r is equals to 1.29. Then we get r. To take theta is equals to tangent inverse of 0.9889 over 0.8337. It will result for an angle 49.87. Always remember that the theta in the exponential form of complex number is a region. So after getting the theta, 49.87. Convert it into region form. And we can get 0.277 pi. So the exponential form of cos 1 minus k is z is equals to 1.29 e raised to 0.277 pi.
Wow, fantastic, baby.